So here we'll talk about evaluating compound propositions. So a compound proposition can be created by using more than one operation. So for example, P or not Q is evaluates to true if either P is Q or the negation of Q is true. The order in which the operations are applied in a compound proposition, such as P or not Q and R, can affect the truth value of the proposition. So when we don't have parentheses, our rule is that we do the negation first, then the conjunction, and then the disjunction. So this is our order of operations if there are no parentheses. However, we do try to use parentheses as much as possible to avoid confusion. The only exception to that is we usually do not use a parenthesis with the negation operation. It should be understood that that should always be the first operation. So a truth table for a compound statement will have a row for every possible combination of truth assignments for the statement's variables. So if we have n variables, there are 2 to the n rows. For example, this compound proposition, P or R and not Q, has 3 variables, P, Q, and R. So we have 2 cubed, or 8 rows. And this is an example of the truth table for this statement. If you notice, the truth values for P, Q, and R are unique for every row. And then we can evaluate the final column. Sometimes this is not the best method. It may be hard to figure out exactly what the truth value for the last column is just by looking at it. So a lot of times we'll complete intermediate columns for smaller parts of the full compound proposition to be a little more helpful. So for instance, for this example, we have P, Q, and R. We can then look at not Q. Since that's in my statement, I can look at P or R, and then I can take the final result. So for not Q, if Q is true, not Q is false, and if Q is false, not Q is true. For our OR command, we need one or the other to be true, or both. So when we have P and R true, we get true. P and true is R is false, gives us true. P and R are both true gives us true. A true and a false and a true. A false and a false gives false. False and true gives true, and then false and false gives false. Now our final statement will look at a conjunction of these last 2 columns that we've just filled out. So we would need both of these to be true. So we see we get true in the 3rd, 4th row, and then the 7th row.